Good morning, everybody. I'm grateful for the organizers for giving me this opportunity to talk here in beautiful Brussels. And I'm going to shed some light how these previous topics actually relate to septic acute kidney injury. And so I received funding from the Academy of Finland. It's not a conflict of interest. And so I'm going to start with some pathophysiological concepts, and then I'm going to show some preliminary results from our own analysis about some of the biomarkers related to endothelial injury in septic AKI patients. So as you probably already heard from the previous presentations, so we have the endothelium is a structure that covers all the vessels in the body and works together with multiple signaling methods to regulate hemostasis, vascular function, and immunology. And here we also, in terms of critically ill patients, the most prominent functions are probably the regulation of permeability barrier and inflammation, as well as hemostasis. And here we see again a picture of the GLYCOCALYX layer, and I'm not going to go very much in details because we already heard Professor Shapira's talk about this, but I'm going to show how this is related to the kidneys. So these are very beautiful figures from Dr. Okada's work, published in Critical Care in 2017. And here on the left we see a normal glomerular capillary epithelium that is fenestrated endothelium. And the GLYCOCALYX there is the broccoli-like structure, and you see it's beautifully covering the endothelium. And in the kidneys, this GLYCOCALYX barrier forms a part of the permeability barrier together with the endothelial cells and the podocytes that are on the other side. However, this was an experiment in mice. So when they received LPS injections and developed sepsis, we see that the GLYCOCALYX started to shed, and also the permeability was compromised. However, very interestingly, the endothelium has a capacity to grow the GLYCOCALYX back, so these changes were reversed after approximately 24 hours. But in humans, actually, these GLYCOCALYX components can be measured in urine, and these associated with acute kidney injury. Again, so as you already heard, so the GLYCOCALYX is just the first component of the permeability barrier, and then there is the intracellular junctions, and after the GLYCOCALYX is shed, the endothelial cell layer is more prone to damage and signaling from inflammation mediators and cytokines, and these can work together to open the tight junctions between the endothelial cells. So we are going to concentrate on the consequences on the kidneys. So as the kidney receives the blood flow to the kidney is very prominent per minute, and if the endothelium in kidney is damaged, so it will increase the fluid loss to the kidney interstitium, and this will cause raised interstitial pressure and renal edema, and this will compromise the filtration function because of the raised tubular pressure, and this can be a mechanism that will predispose the reduction in kidney function and urine output, and that is what we see clinically when we treat these patients. And the question is, how could we actually measure this? So this is a consensus paper from the Acute Dialysis Quality Initiative, published a couple of years ago by Professor In. And here we see that there are a lot of rather sophisticated methods, and biomarkers actually come up pretty often because they are maybe a bit easier to measure. But of course, combination of a sophisticated imaging method together with the biomarkers would probably be the golden tool here. But what we did, or actually I'm going to first list what we actually know about this. So there are some biomarkers that have been associated with acute kidney injury in different cohorts of critically ill patients. And this is just a non-exhaustive list about the previous studies, but we see that the SOLVE thrombomodulin, the STM here, has been associated with AKI several times, but only in one septic cohort, and that was actually a very well conducted study, but it could not show that the STM levels rose already before the development of AKI. And other markers are here the SDC1, the Syndecan1 that was covered previously. So that could not be associated with AKI in septic patients. Angiopoietin 2 is also an interesting molecule in terms of these issues, and it's been associated with creatinine-based AKI in a septic shock cohort. And so we decided to study these things further, and we used the cohort, the Finnish acute kidney injury study cohort that we collected a few years ago, and we selected those patients who had sepsis at the time of ICU admission, and we measured several biomarkers from the sample obtained at ICU admission, and eventually we studied over 600 patients. And here are the markers that we analyzed. So as a component of the GLYCOCALYX, the Syndecan1, and from the endothelium, angiopoietin 2. And they actually have an interesting interplay there because some data have shown that angiopoietin 2 can actually increase the shedding of Syndecan1. And also angiopoietin 2 has, in very preclinical research, has been shown to inhibit thrombomodulin, and Syndecan1 and vascular adhesion protein 1 that we also studied have been shown to correlate previously. And that's what, so we decided to study these four markers. And in our study we had AKI defined by the Kidney Diseases Improving Global Outcomes criteria using both the urine output and creatinine criteria and the renal replacement therapy. And here are what we saw. So here we grouped the patients according to whether they had AKI at any time during the ICU admission or whether they did not have. And here you see the median levels of the biomarkers, and all of those except for the vascular adhesion protein 1 were higher in the AKI patients. And then we wanted to be precise about the timing of the AKI, and we excluded those patients who already had AKI at the time of the biomarker level measurement, and we saw that also in that case, Syndecan1, angiopoietin 2 and the sulfur thrombomodulin levels were higher in those patients who were about to develop AKI compared to those who did not have AKI during the ICU stay. So these were really interesting results. And finally, we did a multivariate modeling and also about some confounders. So as you here in the green, you can see the unadjusted odds ratios for development of AKI after maximum 12 hours from the ICU admission. And in blue, you can see the intralectin 6 adjusted odds ratios. And finally, in the light blue, you see the multivariate adjusted odds ratios. And we adjusted for a number of variables after univariate model selection, and we believe that this is a pretty. We were able to adjust for really important confounders, and finally we found that actually only the sober thrombomodeling 1, sober thrombomodeling was associated with the development of AKI, and also angiopoietin 2 was kind of associated, but because we also had some other endpoints in this study, we had a sort of statistical significance level. But to conclude, the damage to endothelium in the kidneys is important because it's likely to increase the intracapsular edema and further worsen kidney function. And this is very interesting because the way we are used to treat oliguria is often that we give more fluids, and then if we already have a sort of leaky vasculature in the kidney, and that's the reason for reduced urine output, and we want to put more fluids in the patient to enhance the diuresis, so that may not be the wise thing to do. And in our study, we found that there's several markers associated with AKI, and these findings also were robust in that way that the biomarker levels were higher before the development of AKI. And however, only the thrombomodeling was associated with the development of AKI. But this all comes to the point that this is a very important issue, and this endothelial injury is definitely sort of maybe a bit underappreciated thing in the critical ill patients, and we are really happy to have Professor Inns and Nathan Shapiro too, who have really done great progress in this field and developed new methods of studying these issues. And with that, I thank you.